Welcome back to another explainer. Have you ever stood at a busy port, looked up at thousands of tons of steel and cargo just dangling high in the air, and wondered, how does all of this not just come crashing down? Well, today we are unpacking the rigid, largely invisible safety matrix that keeps global docks from turning into disaster zones. We're talking about a super strict framework of maritime rules, heavy-duty maintenance schedules, and intense inspections.
Here is our roadmap for today. We're going to break this whole system down into 6 parts. We'll start with the rulebook, map out the personnel matrix, define the gear and appliances, throw them through the testing gauntlet, review inspections and maintenance, and finally, take a really close look at the care of crane wire ropes. All right, let's jump right into section 1, the rulebook. So we have to start with the foundation, because these safety protocols, they are just polite local suggestions. The maritime industry operates on massive international baselines. It all really started with the International Labor Organization, the ILO, specifically ILO Convention 32 way back in 1932, and then Convention 152 in 1979, which set the modern gold standard for lifting appliances and loose gear. From there, those international guidelines cascade right down into national laws. Take India, for example. You've got the Indian Dock Workers Act of 1986 and the Indian Dock Safety Regulations of 1990. These laws apply to literally all commercial ships doing cargo operations in major ports. It's this seamless global web of safety law.
Moving on to section 2, the personnel matrix. Let's move up the hierarchy to the actual nervous system of the operation, the people. You know, in maritime safety, legal titles aren't just flashy corporate jargon. They carry literal life or death weight. The rules explicitly define who is legally allowed to do what on a dock. Because if the wrong person signs off on a heavy lift crane, the entire legal chain just shatters. At the very top of this food chain, we have the competent person. This is the ultimate authority on the ground. To be a competent person, you need formal government approval, like from the Chief Inspector of Dock Safety, and you need serious, specialized expertise. This is the only person legally permitted to run the most critical statutory tests, conduct deep, thorough examinations, oversee crazy metallurgical processes like annealing, and actually issue the official certificates of test and examination. And then we have a really important distinction between 2 other key roles out on the deck. On one side, there's the authorized person. Think of them as your technical specialist, someone appointed to handle very specific, highly technical tasks that require specialized know-how. On the other side, you have the responsible person. They're appointed by the ship's master or the company to manage the vital, day-in and day-out routine duties. We're talking about things like the daily visual inspections of gear to make sure everything is running smoothly. Which brings us to section 3, defining appliances and gear. Now, knowing exactly what these experts are staring at all day is crucial. The law draws a really hard line between 2 distinct types of equipment. First, you have the lifting appliance. Think of these as the big muscles of the ship, the massive cranes and derricks that are doing the actual heavy lifting. Then you have the loose gear. This is basically the connective tissue. It's all the smaller but equally vital attachment components, like the shackles, the heavy chains, blocks, and hooks that connect the big machinery to the cargo itself. But here's the kicker. Whether it is a colossal lifting crane or just a single loose shackle, every single piece of gear absolutely must be stamped with its Safe Working Load, or SWL. This is the absolute certified maximum static weight limit that the gear can safely handle. And if a massive appliance has different SWLs depending on how it's configured, there has to be a totally foolproof way for the crane driver to instantly know those limits. No guessing allowed. Okay, so we know who's in charge and we know what gear they're monitoring, but that leaves a pretty massive question, right? How does the industry actually prove that a steel beam won't suddenly give out and send a shipping container crashing down onto a busy port? Let's find out in section 4, the testing gauntlet. Let me tell you, they push this equipment to its absolute breaking point. Before a crane even lifts a single real container, a competent person puts it through hell. First up is the static test. They use these massive deck-fixed spring or hydraulic balances to build up an immense test load, and the machine just has to hold that insane pressure perfectly still for 5 agonizing minutes, followed by a microscopic exam for any damage. But, you know, real life isn't static. So they also do a dynamic test. They lift gigantic deadweight proof loads and violently swing the boom across its extreme slewing and topping angles to guarantee the whole rig is stable, even in aggressive swinging motion. Now, all that stress causes metal fatigue. To prevent the gear from just shattering one day, they use a fascinating process called annealing. It's a highly controlled heat treatment where the metal is superheated above its recrystallization temperature, soaked in that heat, and then cooled down incredibly slowly. This actually changes the metal's physical properties. It relieves the internal stress and makes it more ductile, which basically means the metal will bend a little bit under stress instead of just snapping without warning. Pretty genius, right?
Next up, Section 5, Inspections and Maintenance. So beyond those extreme initial tests, there is a relentless, legally mandated schedule of maintenance. And pay attention to the sharp legal contrast here for maintaining cargo gear. An inspection is a routine, daily visual check by a responsible person, just to ensure things look okay. But a thorough examination, that is a deep, highly detailed assessment by a competent person that actively tests for strict legal compliance. And every single bit of this, the periodic thorough exams, the inspections, it all has to be meticulously documented in the chain register. Think of the chain register as the ship's ultimate safety logbook. It contains the actual certificates of test, the precise dates of any annealing, and the official signatures of the competent persons who signed off on the gear.
This creates a wildly strict timeline. Safety scales up over time. Point 1 is the mandatory pre-use visual check of the loose gear. That escalates to point 2, which is the annual review, where all appliances and gear get that deep, thorough examination every 12 months. Finally, at point 3, every single piece of gear faces a massive, mandatory full test by a competent person every 5 years, or immediately after any major repair.
And speaking of loose gear, here's a totally fascinating non-negotiable rule about chains. Alongside the rule that chains need a monthly thorough inspection by a responsible person, you can absolutely never, ever shorten a chain by tying a knot in it. It sounds like common sense, but tying a knot immediately focuses all the stress onto the metal links of that knot. It completely destroys the chain's structural integrity and instantly voids its safe working load. Finally, let's look at Section 6, Care of Crane Wire Ropes. For our last section, we have to talk about one of the most highly scrutinized components on the entire ship, the crane wire ropes. Every ship legally has to carry its current rigging plan, but the wire ropes themselves are on an aggressive timeline. They start with a statutory test by a competent person. Once they're in use, a responsible person has to do a periodic inspection at least every 3 months. But listen to this. The literal second a single wire strand breaks on that rope, the inspection schedule shifts into overdrive. From that moment on, that rope must be inspected at least once every single month. And this right here is the magic, slightly terrifying number, 10%. If a responsible person is doing their check and finds that just 10% of the total wires are broken in any length of 8 diameters, or if there's excessive wear or corrosion, that's it. That entire wire rope is legally unfit. It must be immediately rejected and pulled from service. There is literally zero margin for error. Even repairing these ropes is governed by crazy strict math. If you're making a thimble or loop splice to terminate a rope, the regulations mandate exactly 3 tucks using whole strands, followed by exactly 2 tucks with half wires cut from each strand. It's a highly specific, standardized method just to make sure the splice doesn't completely unravel when you put thousands of pounds of tension on it. So we've walked through the international laws, the immense static and dynamic tests, the complex chain registers, and the strict hierarchy of competent and responsible persons. But it leaves you with a really profound realization, doesn't it? What happens if just one responsible person misses a 10% wire break during their daily routine visual check? It really highlights the immense, quiet weight of responsibility resting on human diligence to keep global shipping moving safely, day in and day out, without a catastrophe. Something to think about next time you see a shipping container hoisted into the sky. Thanks so much for joining me on this explainer. Keep wondering and keep learning.